So, welcome everyone. My name is Felipe, and I will be your host for today's webinar on powering real-time apps with ScyllaDB, with a special focus on our low latency and linear scalability capabilities. When we talk about real-time applications, low latency is typically going to be the primary metric towards measuring the efficiency of your database. And having a low latency data store paired up with a data modeling optimized for high concurrency and fast lookups becomes crucial for your end user experience. If your database is slow to answer queries, then that means everything else in your stack is going to become a bottleneck, which explains why more and more teams are giving a special attention to databases like ScyllaDB. Now, contrary to popular belief, low latency is just one of the main aspects that we needed to consider for real-time applications. Another one, which is often overlooked, and Pete, my buddy joining me here today, is going to talk about, is the ability of your database to linearly scale. Linear scaling ensures that the price performance of your database always remains constant and also helps to ensure that the algorithms employed by your database vendor are efficient no matter on which platform, be it either on the cloud, Kubernetes, or on-prem, no matter which platform you're running. Now, real-time applications are notoriously known to have unbounded concurrency, where you may have a peak of requests, such as when a particular item goes viral, and you can't, or maybe you don't want to, simply throttle down your end users, your requests, as doing so may have a direct impact on their experience. Therefore, as your workload grows, eventually you will need to scale your infrastructure to support your increasing demand. And that's when linear scaling comes into play. So today in this webinar, let's deep dive into each of these aspects and understand how and why ScyllaDB is the database for high throughput and low latency types of applications. But before we do, let's go to the next slide and introduce what ScyllaDB is. So for those of you who are not familiar with ScyllaDB yet, it is the database behind game changers, which are essentially organizations whose success depends upon delivering engaging experiences with impressive speed. Why is that? ScyllaDB was built with close to the metal design that squeezes every possible ounce of performance out of modern infrastructure, which translates to predictable low latencies, even at high throughputs. And with such consistent innovation, in the next slide, we are going to see that the adoption of our database technology has grown to over 400 key players worldwide. Can we switch, please? Thank you. And so many of you will recognize some of the companies over here, such as, for example, Discord, who uses ScyllaDB to support several real-time interactions every single day, or Hulu, who uses ScyllaDB behind the scenes to stream engaging experiences to several users around the US, also at real time, and Optimizely, who gave us a magnificent talk earlier this year discussing how one could maximize ScyllaDB's concurrency. All right, so if you are already using ScyllaDB to power your real-time apps, or if you are considering to use ScyllaDB, be also sure to check out their talk. Anyhow, seeing all this magnificent list, we can see that ScyllaDB is basically used across many different types of industries and for a variety of use cases. All right, so if you'd like to know more on how ScyllaDB could help you, just reach out to us and we will help. All right, let's move on to the next slide. And well, quickly introducing myself, I am Felipe Mendes, and I work as a solution architect here at ScyllaDB. My main role is, to work closely with users during their ScyllaDB journey, gather their requirements, offer consultation, and ensure that ScyllaDB is the right solution for your needs. Along with me today, we have Pete, and Pete, Pete is essentially the person who built up all this amazing presentation for today. And could you please introduce yourself?
Hey, thanks, Felipe. Hello, everyone. I'm Pete Avon. So I'm a solution architect at ScyllaDB as well. I've been here a few months, but I've been working with databases for 20 years, SQL and NoSQL. So a lot of expertise when it comes to databases. And so I'm excited to be here at Scylla. I'm excited to show you what we've put together for you here today. Before I move forward, I just want to say, those customers we highlighted, those aren't all of Scylla's customers. And another thing, if you go to our website, one of the things that got me excited about Scylla is we have these wonderful videos on our site. They're available on YouTube too, but easy to find on our site, where those organizations talk about their migration paths, how they transitioned from, Cassandra or Mongo or Postgres to Scylla, right? And they talk about the challenges they had and then how Scylla works for them. And it's great when you hear it in their words, right? So some wonderful success stories there, and wonderful to hear it from their developers and their architects. Anyway, just want to put that out there. But we'll get started. So very quickly today's agenda, we're going to demo linear scalability of ScyllaDB Cloud. Same rules apply if you're not on the cloud, but we're showing you the cloud today, right? This is where the demonstration was done. And we're going to demonstrate this with workloads of 200,000 ops per second, 1 million ops per second, and 2 million ops per second. We'll follow this up with a quick Scylla architecture overview, like, essentially how is Scylla built? How is it able to do what it does, right? What is the secret sauce here? And then we'll go into Q&A to answer your questions. Okay, so first some context. So for this demonstration of linear scalability, we wanted to base this on something real, right? So we modeled this after a machine learning feature store use case, which is something we're seeing more of. And so, machine learning 101, right? Essentially, in programming, you write a function and you give it some input and it generates data as an output. Machine learning, we turn that on its head, right? We get a whole bunch of data, we feed it to an algorithm and it generates a function, right? It generates the function that we can then give some inputs to, and the data, and it will generate features, which are some measurable properties or characteristics about that data, right? So a feature store is essentially a database for features. Now, this workflow I described, there's typically some database for the training data or some repository of training data. You're doing some training off of that data to generate your models. You're training the models. Those models go in a database. They need somewhere to be stored. And then you have your features, right? And these can be up to 3 different systems, right? And so what some of our customers have found is, because we're massively scalable and because we're the database for high throughput, low latency applications, right? Because of the performance, they can store all 3 in a single system, right? And so with that, we have a feature store use case, 70% reads, 30% writes. We preload the system with 1 billion rows before taking the benchmark. And we're always aiming for single P99, single millisecond, P99 latencies. So P99, what is that? For those who don't know, right? I think everyone here probably knows, but in case you don't, that's the 99th percentile. So 99% of the time, you want response times for your reads and writes within milliseconds, right? So our P99 latency, that's what Scylla is optimized for, essentially. And we scale this out. To make this demonstration, we're scaling out the N2 HiMem 32 instances on Google Cloud. We actually did this demonstration at Google Cloud Next back in August. And so, the reception was really positive. And so I think that was the impetus for this webinar, to be able to share the demonstration, the results with you. But certainly you can recreate this test on AWS. Scylla Cloud's available on AWS and Google Cloud today. For the managed service, that's the database as a service, Scylla Cloud. Of course, the enterprise version on-prem. On-prem today means private cloud, right? So you can certainly run this on Azure, Alibaba, and get similar results. But for Google Cloud, this is what we did. So we're starting with 200,000 ops sustained, right? So ScyllaDB, you should know, is 100% compatible, completely compatible with Cassandra. So if you have Cassandra developers or you're familiar with the Cassandra ecosystem, all those tools that work with Cassandra will work with Scylla. And so one of those tools is Cassandra Stress. It's a benchmarking application that allows you to stress test, Cassandra and Scylla clusters. And so we set up Cassandra Stress with 3 nodes, 3 loaders, essentially, to load 1 billion rows, but then they're going to hit our Scylla cluster with 200,000 ops per second. We gave it a sort of, if you go to our developer, our dev hub, ScyllaDB dev hub, we have an implementing a feature store, sort of getting started use case. And we use that as the template, right, for the data model, as well as the reads and the writes. You can inform that with Cassandra stress, and then you designate how much, 70% reads, 30% writes. Our ScyllaDB cluster, it's a 3 nodes. 3 nodes make a cluster in any distributed system, right? There are 3 N2 high mem 32s, so total vPCUs is 96. So RF equals 3 and CL equals local quorum. So for those that don't know, right, ScyllaDB has high availability built in. And so what that is whenever you save some information, some piece of data to ScyllaDB, you're going to save more than one copy of that data, that extra copy. This is called the replication factor. So if I save one record, my replication factor 3 means I actually want three replicas of this particular piece of data. And we're going to share that data. We're going to store that piece of data across the different nodes. So when you deploy a 3-node cluster of ScyllaDB, right, you're going to deploy, each node's going to be in different availability zone, right? This is the idea. If you lose an availability zone, right, you got the other 2 nodes available, so there's no impact to your applications, but you also replicated the data to those nodes. So you don't, you're not dependent on that 3rd node for the data as well. You're able to maintain, the business can continue while you get that other node or availability zone up. A little more there, Scylla, you can distribute us within a region, you can distribute us across regions, right? So we're massively scalable. But RF equals 3, this is like, so if I store 1 terabyte of data, I'm going to be storing 3 terabytes of data, right? This is the best practice in Scylla. CL is consistency level, right? So your replication factor is high availability. Your consistency level is essentially, we have tunable consistency, right? Scylla can be used as an eventually consistent system, but you can dial this all the way up to completely linearizable, transactions. Now we fall somewhere in between with the majority of our customers, right? So local quorum means whenever I make a write, two of the replicas have to acknowledge the write. Well, in this case, because we have 3 nodes, right? But it's essentially the majority of nodes in the cluster have to acknowledge the write before it's considered a transaction, right? This is tunable, but we're letting you know here, basically on these benchmarks, we're not cheating. This is a long way of telling you, giving you a little bit of, hopefully educating if you're not familiar, but also letting you know, like, hey, this is what it looks like in action. If you're putting this in production, you're probably going to have RF equals 3. You're probably going to be using quorum. Local quorum means within the data center, right? The majority of nodes have to respond to acknowledge the read or the write, right? And then the additional nodes will eventually get that read or the write when they get it. And then of course, repairs happen in the background to make sure everything stays in sync. All right. So to get started with this, right? If you log into ScyllaDB Cloud, which you can, and it's you can get started with ScyllaDB Cloud free today. This is the database as a service. The first time you log in, you're going to see the create a new cluster. You won't see any clusters deployed. You see one here. This is the one we deployed. So any good database as a service has a web UI, web portal to get started. Now you're going to want to programmatically do this. So we actually do have a cloud API and a Terraform provider. And so for these demonstrations, we actually used the Terraform provider and the cloud API to deploy our clusters. And so what we're looking at here is a 3-node cluster of M2 high mem 32s. And we can drill down on it to get some more information, right? And this is what it looks like in the portal. So we have one data center. It has 3 nodes, information about the location in the nodes. But what we really care about, across the top, there's other tabs. One's for connect. If you went to that tab, it would show you essentially different ways for applications, APIs to connect to the cluster you've just deployed. VPC peering, if you need to enable that, we make that simple to do too. But monitoring is your best friend in ScyllaDB Cloud or in ScyllaDB, right? Monitoring is available outside the cloud as well. And monitoring allows us to look at what's going on within ScyllaDB. And this is where we're going to look at our demonstrations of linear scalability. So with regards to monitoring, I think I should also mention, I think let me just make sure I don't forget anything here. So this is basically Grafana, Prometheus and Grafana dashboards, right? And we provide like 5 or 6 very rich dashboards of all sorts of information we think is very useful for monitoring ScyllaDB, the cluster, the operating system, and actually the CQL queries and the queries that are hitting the cluster, right? Of course, if you want to use your own monitoring applications, the Prometheus is available as an export as well. So you can, plug that into Datadog or New Relic, your existing monitoring applications. But ScyllaDB monitoring, the monitoring stack available on ScyllaDB Cloud and also on-prem, is available out of the box. Very simple to set up. And so what you're looking at here, when we look at the overview, we see we have 3 nodes, 0 unreachable, 0 inactive. Scylla Manager is online. Scylla Manager handles background processes. It handles backup, restore, and backup management processes for repairs. But what we care about here are our average writes and reads, right? So our 99% write, 99% reads, these are our P99s. And we see we're in the microseconds, as well as for the average reads and writes are actually P95s. 201,000, requests per second. Load is at 40%. So 40% CPU utilization, right, is what this is really, about. And if you look down below, if you were to scroll down, it would continue to scroll. But we can see like the different metrics for the individual nodes and some information. You see, when we do this mouse over here on the writes, we can see that, hey, there's 40.2 KOPS per second currently with the writes. And if we were to hover over reads, there's about 161 ops per second with the reads, right? So when you're out of the box with the overview, you get the data center overview, but you can get more granular, of course, with Scylla. And so you can actually look at the individual node level metrics. And so this tells us, for one of our nodes, it's getting 67,000 ops per second. Its load's actually 35%. Still reads and writes in the microseconds, right? But then because of this, we're written in C++ in our shard per core architecture, which we're going to talk about, we can get super granular. Essentially, the way Scylla works is when you load data into Scylla, Scylla's automatically going to partition that data for you across partitions or shards, right? Each shard is going to have its own CPU essentially managing it. Each partition gets managed CPU, memory, disk, and network, right? Just for that particular partition of data. And so what you're looking at here are the monitoring screenshots for the writes and the reads. And for people who are counting quickly, now these are 32 vCPU machines, and what you're seeing is actually 30 vCPUs for the writes, 30 for the reads. What happened to the other 2? Well, typically what we do is when you're two of the vCPUs we'll use for background processes for maintenance, for some of the autonomous self-optimizing processes of Scylla in the background. But when you look at monitoring, yes, you can get these individual metrics, and it looks like, hey, the reads and the writes are evenly distributed. We like this. You also have these charts, the lines you see going across. This is very useful because you're going to distribute your data. And of course, right, the way for things to be optimized, you want the data evenly distributed, but you also want your queries to be evenly distributed. So if we had a hot node or a hot shard, you'd see essentially, right, one of these lines higher than many of the others. And that would help us identify, hey, what's going on with this particular shard? What's going on with our access pattern? We need to look at that to help get this in more alignment, right? So everything looks good here for this test, right? We've got the reads and writes per shard. Everything's looking evenly distributed. Everything's wonderful. So we're going to continue the testing, right? And basically, yeah. So for the next test, it's 1 million ops per second sustained. And so for that, right, we're going to still three Cassandra trust loaders, but we're just going to crank up their reads and the writes to 1 million ops per second. Again, we've loaded 1 billion rows before running the benchmark. But now we're going to use 15 of the N2 high mem 32s machines, again with RF equals Siri and CL equals local quorum. Total vCPUs equals 480, right? And so for this one now, again, we have 15 nodes, right? And again, the idea here is the way we're demonstrating this for you is, and we demonstrate this at Google Next, is as we increase the load, as we increase the operations per second, the utilization remains at 40%, and the P99s remain stable, right? So you can make educated, essentially you can do math to figure out exactly like, hey, if I scale out, how many machines do I need to do that? And based on that, I also understand my cost, right? So predictable cost, predictable performance. And so again, we've got the microseconds on the P99s now at 1 million operations per second. Our load's still at 40%. Now, finally, 2 million ops per second sustained. We needed 6 loaders to do this, right? To crank this up to be able to do 2 million ops per second. So now we've got six nodes hitting 30 ScyllaDB clusters, 960 vCPUs. Same rules apply, right? With RF equals 3, C equals local quorum. And I bet you can guess that, of course, the performance is sustained, right? Microseconds on the P99 reads and writes, and the requests at 2 million ops per second, and the load at 40%. So this is a very simple way of demonstrating linear scalability for this particular workload, right? And we're showing you screenshots because, hey, there's a whole lot went into this, and we're like, it's fun for me to tell you. We'd love to show you with your data if you're interested, or you might want to see this with your data, right? But the idea here, I don't want you to get hung up, is you don't need 30 nodes to service 2 million requests per second, right? Again, we're demonstrating linear scalability here. The idea is, as I add these nodes, I have sustained performance, sustained utilization of resources as I add capacity in some linear manner, right? But if we go back to our 3 node, our 3 node, when we started with 220K, right, ops per second, we had room for growth there. And so if we wanted to scale to, for 1 million ops per second, we can, for this particular workload, we could actually handle this with 9 nodes, right? Now you'll notice, so the P99 reads went up to 1 millisecond, the microseconds is still on the writes, but essentially the CPU utilization went up to 58%. So, Scylla written in C++, it's really smart about the allocation of resources, and it's always focused on the latencies, on the P99 latencies, and optimizing for that, right? So now we have 1 million ops per second with 9 nodes into high mem32s. Nothing else has changed in this BIM arc. Billion rows loaded, RF3, C equals local quorum. This is just to show you, hey, and this system has room for growth, right? Usually it's 70% utilization, and also we're not even talking about storage, right? You'd start thinking about adding more nodes, but this system can obviously take more load for this particular workload. But when I go to 15 nodes, we can actually do 2 million operations per second with 15 nodes. CPU utilization is now at 69%, right? But notice those reads, they're still at 1 millisecond, right, for the P99 reads. And our writes, they've inched up a little, but they're still in the microseconds for our reads and our writes. So this is the fun stuff. How does Scylla do all this? So the founders of Scylla were the creators of the KVM hypervisor, right? That was subsequently purchased by Red Hat. They understand the allocation of system resources at a very granular level. They wrote Scylla in C++. They wrote the KVM hypervisor, and then they wanted to apply that to a database. And so what they've done is pretty genius, right? So a little history, right? So Scylla is like the next generation wine column store. In the beginning, there was DynamoDB and Bigtable. And then the people who invented Cassandra looked at that, took the best parts of those databases, and invented Cassandra. And Cassandra was wonderful for its time, but it's written in Java, right? So anyone who who's worked for the database in Java, the enemies are JVM tuning and garbage collection. These things just impact you to a freaking great degree, and you end up a lot of times, they totally affect performance, especially at scale. The idea is when I'm going 1 million ops per second or 2 million ops per second, and I need high throughput, low latency, and I need that sustained. When you start doing some of these background processes, or you're inserting data and you're reading that data and you're managing the data, garbage collection kicks in. It can be a big impact to performance. And then you try to tune and model your way around that, but it becomes a freaking a no-win situation. It's a battle you can't win. So that's one of those reasons I go back to those videos, those testimonials. I can say these things, but it's great to hear the architects and developers for the companies we work with talk about it. Not everyone's a Cassandra case, but we have plenty of examples. The other thing that happens with Cassandra is, we can typically do what Cassandra does with a fraction of the nodes. So Comcast, if you go listen to their case study, they went from like 400 nodes of Cassandra, and they were having problems with throughput and latency, the challenges because of garbage collection, and they went down to like 40 nodes of Scylla. I'm not even exaggerating, or it's like 70 maybe. I'm not trying to exaggerate, but they went down to double digits from hundreds, because it's just more efficient. So they could service the same workload with better performance and less cost, right? So how does this work? Written in C++, we have the shard per core architecture. So again, 3 nodes make a cluster. We have 5 nodes on the right here, right? And so when data put into this system, we talked about replication factor. We're going to, if RF equals 3, we're going to store the data on one node, but we're going to store it on 2 other nodes as well. So we have three replicas of the data. Now the data is automatically put into shards. These shards essentially are, think of them as the core, whatever your partition is. So your record has a key, the primary key. It becomes the partition key. Scylla distributes this data based on a hash of course, right? Because in any distributed system, for this to work properly, the data needs to be evenly distributed across the nodes, right? Or you end up with basically lopsided workloads, hotspots, etc. The way it's distributed, though, at the next level, there's the node level, right? But there's also this partition level where each node, each shard gets its own allocation of processor, memory, storage, and network dedicated to that particular partition, right? It's one of the reasons it's so blazingly fast and good at what it does. So built in C++, system and data center aware, right? So essentially, when you install Scylla, it understands, it looks at the resources available to it and will allocate to itself, what it wants accordingly based on what you have in the system. There's sharding per core. And we also have shard-aware drivers. So I mentioned like the Cassandra ecosystem of, drivers all work with Scylla, but and drivers are node aware. And this is a way of saying my application needs to go to a particular node, right? And well, let me back up. For those who might not know, right, when I come in and make a request to Scylla, every node is readable and writable, right? There is no master secondary. There's no primary secondary in Scylla. Each node is, I can connect to any node and read and write, get a complete view of the database, right? Now, if I go to any particular node and request data, I want the data, hopefully to be on that node, right? So I can return to the caller really quickly what I'm looking for. And so you want to use when you use the existing ecosystem of drivers, they're node aware. They understand, hey, maybe where the node resides, so I go to the node I'm looking for. But Scylla takes that one step further. We have shard aware drivers. So when you look at our drivers, essentially the shard aware drivers have that key to the hash map, how we're distributing the data. So I can go directly to the node in the shard that has the data I'm looking for and return it blazingly fast, right? And so auto performance tuning. So again, when you're, if you have this system that's eventually consistent, you've tuned the consistency, but you're doing quorum, right? So there's essentially, when you do quorum, there's reads and writes. Scylla has all sorts of tricks to make sure that the partitions, the data, everything stays in alignment with the latest timestamp. So you have the latest version of the data that you've actually transacted upon, right? And so with that, there's a background process called repair that's going to be handled, as well as things like the garbage collection, but this is done in C++. It's a different type of animal. But there's a lot that Scylla does for you to optimize for you. And essentially, think of it this way: you're reading and writing data. The data is going into the system, but the way that data is going into the system isn't necessarily, it's organized by partition, but now I'm deleting, I'm updating, I'm doing some things. So I have to reorganize that data on a somewhat regular basis to make sure the data is stored in the partition in an optimized fashion, so my reads and my writes stay optimized. And that organization process that I'm calling repair is something that Scylla does essentially as a background process, right? So let me see if I've missed anything. I think, whoops, I did not mean to do that, pardon me. I believe that's it. I think I've hit on everything here. And so with that, I will kick it back to you, Felipe.
All right. Well, thanks, Pete. I mean, that was really impressive. And I think that in general, your talk was just right. I mean, it greatly defines ScyllaDB's core capabilities, which are low latencies at extremely high scale. And you basically prove that we linearly scale. Just one thing, the Comcast story you mentioned it's awesome. I love it. And I highly encourage people to check it out because yeah, it's truly impressive when we compare the numbers on the database they were running before up until now. But okay, so now we are before we actually get started with our Q&A. We have actually collected a series of resources to help you get started on your journey. So first and foremost, be sure to take your time to register at ScyllaDB Cloud by going to scylladb.com/cloud. And you guys are going to find the links easily in the chat shortly for you. Now, ScyllaDB Cloud is the managed service which Pete used during his talk in order to provision the clusters and run the workload he just presented. And you can do so as well. You can easily start a free trial with a few clicks of the button. You can integrate your ScyllaDB Cloud clusters with your existing Terraform resources. It should be very straightforward. And then you can get a look and feel on how ScyllaDB actually performs at scale. All right. Next, we have ScyllaDB University, where we provide free online training, not just for ScyllaDB, but also NoSQL in general. Therefore, if you are coming from a relational background, or even if you're coming from another NoSQL database, you can rest assured that ScyllaDB University has the right content for you. So data modeling, systems operations, integration with CDC and other technologies are just some of the content featured there. Introduction to NoSQL essentials, etc., and so forth. All right. And then, lastly, but not least, we are really proud of being sponsors of P99Conf, which really, guys, it's really around the corner. Just it's going live just 2 weeks from now. And if you have never heard about what P99Conf is, it is essentially a cross-industry virtual event for engineers and made by engineers. And the entire conference idea is to be centered around low latency, high performance design. So we do sponsor the conference, but you will find tons of performance oriented talks over there. For example, in this year's P99, we are going to have, and Pete, help me here. I don't know if you ever heard about those companies such as Meta, Netflix, TikTok, Google, AWS, and Microsoft. I mean, just those smaller companies are going to be featured there in P99. And of course, ScyllaDB is going to be also there. And yes, in the chat, Twitter, Uber, Lyft, all those companies are going to be featured there. So take your time to register because it's free, guys. It's free. Just enter the website, fill out the form, and enjoy the conference. It's made essentially for you. All right, Pete. All right.
Yes, sir.
That was a lot of resources. Yeah. So Pete, let's start with some questions now. Let me see. Yeah. So actually, before I answer you. I made you the first question we have. I want to follow up on a question I already answered because someone asked if ScyllaDB has a driver, hardware driver connector for Spark. So as you know, Spark, the regular Cassandra connector for Spark is basically using under the hood the Cassandra Java driver. And as Pete said in his presentation, the Cassandra driver is by default node aware, and when you switch to the ScyllaDB driver, it will essentially become shard aware. Now, it's really important that you define, that you know what you want to do with the ScyllaDB driver, because if you are going to run a lot of reads, full table scans, not exactly following, because Spark is basically used for analytics, right? So if you are going to be very frequently running full table scans, you may not see any benefit from using a shardware driver because since Spark is going to be very frequently running token range type of queries, those queries will not map to a shard. But if you are going to run a very ingestion heavy process using Spark, then you will see greater latency results because ingestions you are obligated to specify your partition key. So I just wanted to make this point clear with regards to Spark. Now, Pete, question to you. So one of the things that really caught our attention is that across all the workloads that you were demonstrating in your talk, they were actually very far from reaching maximum research utilization, which essentially left some headroom, CPU headroom, to scale further, etc. Can you elaborate on that? Were you basically over provisioned? Why did you decide to run
Well,
the workload like that?
so that was the demonstration was linear scalability, right? So linear scalability is I want to be able to scale out, basically my system with some, equal set of resources to get an equal set of results, right? So when we scaled out from, essentially starting from 3 to 15 to 30, right? The number of vCPUs scaled linearly, the workloads increase linearly. I see the results, my utilization of the resources should stay the same, right? I shouldn't see, if it wasn't linear, then scaling out, I'd need a lopsided amount of resources to be able to add to get the same performance, right? So it was over provisioned, but the point was to show the linear scalability, not necessarily to show, right? Like that's why we went back and we did the 9 and the 15 nodes to let you know, like, because that was my concern. So this was a very, a simple way of demonstrating that everyone can look at monitoring and wrap their head around, right? We could have done tables and charts and stuff, but I was concerned people were going to be like, I need 30 nodes to do 2 million ops per second. And so I was like, no, we got to show them that they don't need that. So I was like, I'm going to do this with 9 and 15 too, and to show people that, like, hey, you can do a lot with Scylla with a much smaller number of resources, right? But really, the impact that it had is people being able to understand. People being able to understand, like, okay, and there's so much we didn't talk about. So when if I have a set of machines, a class of machines, and I know that, like, I need to add, because maybe I can scale out Scylla and I can scale back Scylla. So if I have seasonal workloads, we were just talking to someone yesterday. People are worried about Black Friday. There's another company worried about the Super Bowl, right? People have their times of business. They want to be able to scale out, and they can do that with Scylla really simply. But they also want to know, what does that cost? Because simple, Scylla is really to understand with regards to the system resources and how we price. A lot of people, it's like it's really amorphous, and they're paying a lot of money, and they're not understanding how these resources are being applicated, or necessarily what they're paying for, right? So with Scylla, we're really straightforward about it. It becomes really simple, so they know exactly how many machines they add, how much it's going to cost them, and what it's going to take to be able to get them to provide what they need to be able to service their customers, right?
Yeah, no, definitely. I think that's a great answer. I would only add the fact that across all your
Great question in the chat.
latency numbers, we could see, I could see across all your performance numbers you demonstrated that at worst, your P99 latency was 1 millisecond. And when you are running at such an aggressive SLA, because 1 millisecond P99 is aggressive, you cannot have any sort of research contention at all, right? So it does make sense for you to be slightly, not very tightly over provision, but slightly over provision to ensure that your workload never introduces system contention, which is exactly what can be very detrimental to performance. Right.
Well, the other thing too is capacity planning. Well, I
Mm-hmm.
just want to say capacity planning is never done for today, right? We're planning ahead 6 months, 3 months. I mean, in some seasonal workloads, you have some idea, but potentially, your data retention policies, whatever. So you always want some additional headroom. Hey, we have an excellent question in the chat. You all right if I maybe take a start at this one, or do you want to?
Of course.
Okay,
no,
so
you can really.
so we have a question wondering if Scylla would be a good choice to migrate from MongoDB. Lots of data with dynamic schema and the migration process from Mongo to Scylla. So any good answer is it depends. There's a lot in that question, but Scylla's actually. So this is the thing about Mongo. This is what we're finding. So I'm going to reference you again, because when I say it, it's one thing, but when our customers say it, right? So Discord started with Mongo, social media site, voice over IP. They couldn't get Mongo is great for developer productivity, but it is not good for performance. Right? It hits a certain threshold and it just won't do what it needs to do performance-wise. So we have people moving from MongoDB to Scylla. I said it depends because, hey, we need to talk more about your use case and the particulars. But Discord started with Mongo. They went to Cassandra. They have a story where their nodes were insane with regards to the number of Cassandra nodes, and they moved to Scylla to much fewer nodes, but with greater performance. And it's they've done all sorts of blogs on this. They're developers, they're architects. Another company is Tractian. It's a maintenance
Traction,
service.
yeah. Traction.
Traction, is that how pronounced?
Traction, yeah.
Okay.
So Traction essentially works with IoT devices, and they
Yeah.
send their metrics at real time. Yeah, it's really cool to
And they
build
did,
dashboards. Yeah.
yeah. But they were on Mongo, and
Hmm.
but they hit the limitations, and so they did a bake off of Mongo, Postgres, and Scylla, and people find the performance and scalability of Scylla is so compelling that they migrated from Mongo to Scylla, right? So then, what does that migration looks like? Again, we'd have to talk about the particulars of your use case, but there's definitely a path to move data from Mongo to Scylla. And I should state that Scylla states, you can put JSON data in Scylla, right? So JSON, you can do selects and inserts of JSON. Yeah, interestingly enough, right, it's a wide column store at its heart, right? You can think of this as key value, but it stores JSON. But we're actually used, there's a couple of use cases, well, more than one, there's more than a couple, of a Janus graph as a graph engine, and it has a pluggable engine structure. But people are using that with Scylla because of its performance, so they can query, basically billions of nodes and edges to do graph type queries on top of Scylla. So I'm glad you asked the question, because it's like, hey, it's not just wide column use cases, right? You have to think of it in terms of that's what it is at its heart, but I can have graph access patterns, I can have document access patterns, right? And I can get that high throughput and low latency with Scylla.
Yeah, couple of things I would add to your perfect answer on related to MongoDB. I mean, we just shouted out in the chat a link for a MongoDB versus ScyllaDB benchmark. And guys, this benchmark was not, it's going to be eventually featured on ScyllaDB, but it was not run by us. So it's a third-party benchmark, and you can clearly see the results for yourself. And in this benchmark specifically, we test three different types of workloads. So time series, social, and a third one I don't remember right now. But one of the things that really caught my attention in your question was the fact that you mentioned that you have lots of data, which is good, and your use case consists of dynamic schema. So be very careful with the schema-less nature of MongoDB. I mean, there are several articles from several performance experts and outside of ScyllaDB related to how a schema-less deployment model can be detrimental to performance. So if performance is currently your pain, you may want to rethink the dynamic schema aspects out of your deployment. Remember, with a database like ScyllaDB, sharding is done automatically, so you don't have there's no such thing as dynamically choosing as a sharding key, such as when you're going to build a sharded MongoDB cluster. So yeah, be mindful of those steps. And I think there is another question. So
Well, that
I
was a
went through
follow-up.
several case studies, yes, posted on ScyllaDB website, and found that many companies have opted for ScyllaDB, like Discord. Numberly. Numberly is a great one. There is a talk from Alexis, the CTO of Numberly, where he explains point by point what have been the reasons why he decided to migrate some workloads to Scylla, and why some workloads remained in Mongo. So again, are you ScyllaDB faster than Mongo? Yes, we are. Are we a 100% replacement to MongoDB? No, we are not. And we really don't want to be.
It depends.
Yeah,
That's the thing.
depends.
So I'm with you on right tool, right job. I think a lot of people look for one database to rule them all, and that's not the world we live in, right? It's like, hey, certain databases are good at certain things. There's things that Scylla is really good at. There's things that Mongo is good at. But again, the thing to do is you can try Scylla for free. Get started and get hands on and see what that looks like. And we also have Scylla U, where we talk about data modeling, right? So you can start, seeing what this might look like. Because part of it too is, I understand a lot of people have existing applications. We just like to replace the underlying database without having to change the application, right? In an ideal world.
Yeah.
But hey, when you're messing with data models and you're doing things, it's like, well, then it becomes, depends on your business, right? And what's the pain? And for a lot of people, it's like worth it to move to Scylla, because it solves a particular class of problems that allows them to, basically run their business, right? Get to where they want to be with their business. If you looked at all those people on that game changer board, we're running at the heart of their business. It's like Disney Plus, freaking Strava. It's like we're the database for, it's like so it's these are run the business applications. These aren't like little side projects, right? So
yeah, and if you would like us to help, that's why we are here, right? That's essentially our job, to help you find the right path towards ScyllaDB. Okay, we have additional questions. Do you want to read? Take one, Pete?
I was looking like, how about, which one are we looking at? Oh, we're currently
we have tons of questions. So which
yeah. Which one? Who is next? That's what I was. Oh, so there's one about interim data, right? Which can be reviewed periodically to keep costs low. And so, yeah, I'll just take that one first while I marinate on the Aerospike one, if you want to look at the Aerospike one. So in ScyllaDB, you can set a TTL essentially, right? So ScyllaDB, it's this, it can be used as a massive aggregator for data, and you not necessarily want to keep all that data, right? So you can set a time to live, an expiry date on that data. And so that data can be purged automatically, right? So that's one of the things we offer that can help support that. And we see that with a lot of time series type applications, right? So we are optimized for time series applications. We have a that repair process. There's compaction strategies is what we call them in Scylla speak. And so we have a time window compaction strategy optimized for organizing data with in a time series use case. But yeah, again, if not, then there's other ways to, and then it's like, hey, what Scylla doesn't provide out of the box, there's application logic. But certainly the people who are using us, you can think of it as a hub essentially for millions of users, millions of requests, some amount of data. Oh, what happened there? That was
maybe you pressed the button, but
no,
it's fine. We still love you.
Mind of its own for some reason. But it's not uncommon to remove data from Scylla from some period of time to keep the profile of the database in some sort of consistent level with regards to the data retention.
Yeah. So I wanna take great answer, by the way. I wanna take this next question about Aerospike because I particularly find it interesting. So that's the question. We are currently employing Aerospike for a low latency workload in EdTech, which is interesting. EdTech really has low P99 needs. One of our cluster operates on 14 nodes with 2 million operations per second. So it's just look like what you just showcased, Pete. And ScyllaDB should in theory be performing a similar performance level, you're right. But here's the question, which pros and cons of features might we get from ScyllaDB besides raw performance? Do you wanna throw in some, Pete?
No, I'm not familiar. No, I would let you start with that one.
Okay,
I think for me, these things are better said like, so that's like a product, if I had two screwdrivers and I'm like, which one has a better handle and which one has a finer head and what's the metal made of? It's like a product comparison, like speeds and feeds. For me, it's always about, when I look at that, I'm thinking, well, what's the use case? So ad tech, right? We have ad tech use cases. We are definitely good for ad tech, right? But Aerospike versus Scylla, I'm going to have to, if we've got your name, I can do some research and get back to you on that, with regards to, the product comparisons, but that product comparison comes down to, well, it depends on what you're doing with ad tech, right? There's things we provide, like maybe a change data capture,
of course,
or materialized views, or like things that there are secondary indices. Maybe there's things we provide that are going to be beneficial to your use case that Aerospike doesn't have, right? Or vice versa, right? So that was my. I'll shut up.
No, it totally makes sense. I mean, ScyllaDB has tons of exclusive features, and the question basically asked unrelated to raw performance. So I will try to keep the raw performance ones out of my answer. But for example, one of the things that ScyllaDB has that I have never seen another NoSQL vendor have is workload prioritization, which is essentially a unique feature which makes leverage ScyllaDB isolation capabilities and allows you to run, for example, real-time and analytics workloads on top of the very same data store, and I know what you're thinking. You're probably saying, hey, if I have an ultra low latency use case and I'm going to run analytics on top of it, then my latency is going to suffer. And no, it's not going to suffer, because that's exactly what this feature is all about. It's about you basically hint the database which workloads you want to see prioritized, and with that you can essentially run several use cases altogether under the very same data store. So if you have a need to consistently run reports, long batches, etc., and so forth, that's a feature that you would benefit from. All right. What else is coming? So recently, ScyllaDB, we already have in our latest enterprise 2023.1 Raft. So schema changes are basically are not an issue. And in the future, we are going to continue to leverage our Raft background to provide more and more strong consistency in the database. What's coming, and we even trained it in Hacker News this year, is the notion of tablets. And this is something that I know AirSpike doesn't have, but other databases do have, such as Yugabyte, Google Cloud Spanner, etc., and so forth. But tablets essentially allow your data to be redistributed in real time according to your access patterns. So things like large partitions, they will no longer be an issue. Scaling up, scaling out, scaling down a cluster, those operations are going to be done really, really fast. But again, tablets is something that is still under the works, but we already got some very nice results out of our tests with it. And anyway, ScyllaDB is all about innovation. That's what we try to bring back to our users. What's new, not just in engineering algorithms, which directly relates to performance, but also newer and exclusive features. By the way, I have a blog which talks about the hidden gems ScyllaDB capabilities, which you might want to take a read, because it's really interesting. So I hope I addressed your question. Last one, Pete. We are running out of time.
Well, there's are there any recommendations around batching for Spark Scylla writes? I've observed higher performance with batches of 512 rows per batch, while a benchmark suggested 1 row batch to be max performant. I have not had the opportunity to work with Spark batches. Do you have any input here, sir? Or we can certainly research this one and get back to him.
I have observed higher performance with batches of 512 rows per batch. Yeah, so it depends on how your Spark is configured, because if you are batching several records to the same partition key, then the more rows you batch altogether, the better it is. But if you configured your Spark to batch to different partition keys altogether, then this may later on introduce performance bottlenecks. And the reason is because if you analyze the ScyllaDB write path, once the driver, the client, your application or Spark submits a query to the server, this query will be handled by a single node and a single shard, as Pete explained it. And this single shard is going to be called the coordinator of the query. When you are batching to several partitions at once, what happens is that this coordinator node needs to, ensure that the data you just batched is propagated to all other nodes fast enough. And just basically turns out not to be optimal, because a single shard, a single CPU in this case, is essentially has to coordinate communicating with all other shards and potentially other nodes in your cluster. So it depends on how you configure Spark, on how you're batching, etc., and so forth. If you'd like to know more, feel free to engage with us. All right.
Hey, thank you, sir. Excellent. So, I think we hit them all.
Yeah, we hit them all. And well, with that, can we switch to the next slide?
Oh, all right.
You are the driver today. Well, Pete, thank you very much. That was a very good presentation. I was very glad to have you here with us today. Thank you very much for the audience and for all your questions. And we hope to see you soon. See ya, guys.
Thanks all.